Okay, so let's quickly discuss all the assignment questions. So first one is Monty Hall problem. There are four doors instead of three. Okay, so now as uh, Dr. Prabhochandran taught in his lectures, so one of the important things to solve a problem like this is to have a proper omega. So let's do that. So in omega, let's have okay, so what we will do is we will look at the four door cases, um, but we will have omega will have three components. So the first one is what, so there will be three components like this. This is chosen by the player, okay, and these two are going to be shown by game show host. Okay, so there are four doors. So there is prize, then there is goat 1, goat 2, goat 3. Okay, so now if we try to do this, so there are various ways in this can happen. So the first one, first position can be P, G1, G2, G3. So this can be the three ways in which the first position can be filled. And if P is filled, the second and the third, okay, there are actually three choose two ways, okay, because there are three of them, and the game show host has to decide which two of them to show. Okay, so yeah, so this will be you know G1, G2, G2, G3, G3, G1, 1, 2, 2, 3, 1, 3. These are the ways in which he can show. All right, so that is this. Of course we can do 1, 2 and 2, 1 as different things, but let's not complicate that. Yeah, so what is the probability of having this? This is 1/4. Okay, this is 1/4, 1/4 and 1/4. Okay, and once let's say he has chosen G1, so the other player has no the game show host has no chance but to show 2 and 3. So all these things are okay, this is 1 and 2. All these things immediately happen, and here so 1/4 is this probability, and this will be amongst 1/4 you take a third of 1/4. So this is 1/12th, 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 1/12th. Okay, so this is all the different ways in which we can write omega. I am not writing it, but you can see it will be P, G1, G2, P, like this. Okay, and this is probability happening with 1/4. This is 1/4, 1/4, 1/4. Okay, so now in these three cases, okay, in these three cases, assuming that the game show host is going to show two doors, okay, the probability of winning due to switching is 3/4. I hope that is clear to everybody. Okay, because these three places, if he switches, he wins. So okay, so that was when you show when you the game show host shows two doors. So let's look at the other case. So in the other case, the game show host shows only instead of two doors, shows only one door. Shows only one door. Okay, now the same thing, there will be omega will have two components. The first, what is the player is chosen. The second is what the game show host is showing. So chosen by player, and this will be shown by game show host. Okay, so this will be yeah, so now this will be probability 1/4 he will choose P, 1/4 he will choose G1, 1/4 G2, 1/4 G3. Okay, now given this, now what will happen, the game show host has three choices here. Okay, so either to show G1 or to show G2 or to show G3. In this case he has two choices, G2 and G3. Okay, so G1 and G2, G3, G2 and G1, something like this, right? Now this is total 1/4, so this will be divided into three parts. This is 1/12, 1/12, 1/12. Okay, this will be 1/8, 1/8, 1/8, 1/8, and 1/8, and 1/8. Okay, so now in none of this, so this no wins here. If switch no wins. Okay, if he switches there is no wins here. If the if the candidate switches, the chance that he will win, this will be so 1/8 is the chance that he will like it is in G2, and then if he switches, half the time he will win, so this will be 1/8 by 2, so this is 1/16. Okay, this will be 1/16. So all these things will come 1/16, 1/16, 1/16, and 1/16. Okay, I hope that's clear. And now we add that up, so there are 6/16, the probability of winning if he switches, and this will be 3/8. Okay, so this is question number 1.